All right, let's do another Add Math lesson. This is the last lesson for the week, and what we're going to do now is factorize quadratic equations. So let me put the heading here, and it's factorizing quadratic equations. Now, quadratic equations are encountered in many parts of the CSEC additional math syllabus. Thus, understanding them is going to be an essential topic in the syllabus. This is just the first part of dealing with quadratics, which is factorizing them. And all you have to remember is that a quadratic equation is nothing more than a second-degree polynomial. And you've already done factorization by grouping, so all you need to do is add a little piece on top of that, and you'll be able to factorize a quadratic easy. When we do the examples, you'll see what I'm talking about. Let me start by first giving you a little note about quadratic equations. So a quadratic equation is a second-degree polynomial equation with a single variable. This variable is usually x, right? Which can be written in the standard form. And let me write that standard form here in orange. Ax squared plus bx plus c equal to 0. All right. Now the steps for doing a factorization is very simple, and I'm going to outline that. You know what? Maybe I should also define for you what these terms are. So let me just write something here. This, and this are all constants, right? Constants that are members of the set of real numbers. And in this case, to always have a quadratic, a cannot be equal to 0. All right, a cannot be equal to 0 for you to have a quadratic, because if this is 0, then this term here disappears, and what we have is bx plus c, and then the degree of the polynomial becomes a first-degree polynomial. A quadratic is a second-degree polynomial, so it will always have the situation where a is not equal to 0. Anyway, let me go ahead and put down the steps for factorizing this. So let me put this here. So we can say that to factorize a quadratic equation, we need to rewrite the quadratic expression, I should say expression. Quadratic expression as a product of two binomials. All right, so what we're going to do is we're going to rewrite this part that I'm going to circle here in yellow. All right, we're going to rewrite this part over here. Oopsie, that's not yellow. All right, we're going to rewrite this part of the quadratic here as a product of two binomials, and that will be the factorized form of the quadratic equation. So let me outline these steps here now. So steps to factorize a quadratic equation. All right. The first one, find two numbers m and n such that a times c, I don't know why I write that backwards, is equal to m times n. And also m plus n is equal to b. So we need to find two values, m and n, such that when we multiply them, we'll get the same answer as if we multiply a by c. And also if we add them, we get the same result as b, right? Then we continue from that. So the second step is that we're to use m and n to split the term with b. All right, that's the second step. And then the last one is to use factorization by grouping. All right. So let's see about that. Let's go with an example. We'll start the examples now. All right. So first example is we are required to factorize, and all of these we are required to factorize. Okay. So I'm not going to write the word over and over. So we're required to factorize x squared plus 5x plus 6. Now I'm going to circle these terms here. Right in front of the x, even though it doesn't have a number, it's understood that there's a 1 there. So that's our A. This positive 5 here is our B, and this positive 6 here is our C. All right, so the first thing I want to do is I want to find the product of A and C. So A times C is going to be equal to a positive 6. Let me just put the value. So A times C is 1 times positive 6, which is equal to 6. All right, so A times C is 6. Now, the possible factors of 6 are as follows. Now, remember, we need an M and an N so that when we add them together, we'll be able to get the same value as B, which is a positive 5. Now, we know that positive 1 by positive 6 is going to give me 6. Negative 1 by negative 6 is going to give me 6. Positive 2 by positive 3 is going to give me 6. And negative 2 by negative 3 is also going to give me 6. Oopsie. That's the product, okay? Each one of these is the product for 6, right? Now, I don't want that. I want M plus N. So 1 and 6 is 7. This is negative 7. This is 5. And this is negative 5. So we can see right away that this one here is equal to B. So this is what I would use to split the center. So I'm going to rewrite it by splitting the center. So I'm going to have x squared, and I'm going to write in white what the center is split into. And I'm going to put positive 2x, positive 3x, and then positive 6 is going to go back in pink. I should split that in pink. Positive 6. And we can see right away that now we have 4 terms, and we can use factorization by grouping. So let's group the terms together, and I'm going to group this term here, and I'm going to group this 2 terms here, and factorize them. I will get x into x plus 2, close bracket, plus 3 into x plus 2, close bracket, and then I have x plus 2 into x plus 3. Now, as you keep going on doing this, you would realize in your head that you can calculate this faster than you can write it. So you don't usually write this part in yellow. All right, you don't usually write this part in yellow. However, I show you this so that you can practice it a little bit so you can get familiar with the process in your brain first before you actually start ignoring it and not writing it at all. Right, so this is the process that's supposed to go on in your head for you to figure out the factors necessary to split this B term and be able to get the completed factor. All right, let me give you another example to do. Well, another example. You can try it if you want before you watch the solution. So 2x squared plus 7x plus 3. And we can see that this here is A, this here is B, and this here is C. So A times C would be equal to 2 times 3, which is equal to 6. And we have the exact same factors that we listed up here, but this time what we're doing is we're looking for 7. So what I'll do is I'll change the color to green, and I'm going to say this here is the 7 here, and I'm going to just circle this to refer to this, right? And I'm not going to list them all over again. So I'm going to realize that this here is what I'm going to use to split the center. So I'm going to rewrite the center with green as the highlight color. So 2x squared, and then I'm going to split the center with a green color. Remember, it's 1 and 6, so I will use x plus 6x and then plus 3. And then I'm going to factorize by grouping. So I'm going to group this together, and I'm going to group this together, and I'm going to factorize by grouping, which is x into 2x plus 1, and then I can factorize 3 into, let me just take off this bracket here, I don't need that, 3 into 2x plus 1, and we are going to get 2x plus 1 as a common factor to both, and then 3x plus 3. X plus 3. And that's the answer. All right. let's go again. We're going to do another one. So let me get a new page. Let's say, for example, we have some minuses now, right? Let's put some minuses in there. So we have x squared minus x minus 6. All right, so then we see in here right away that this is a positive 1, so that's our A. We're seeing right here a negative sign, but this is 1 in front of that, which is understood, so that is your B, negative 1. And then your C is this one here, which is the negative 6. All right, so our A times C is equal to negative 6 times 1, which is equal to negative 6. And the factors of negative 6 are as follows. We have a m, a n, m plus n. So we know that negative 1 multiplied by 6 is going to give me a negative 6, and that is a positive 5. Then we know that 1 times negative 6 is going to give me negative 6. Adding those together will give me negative 5. Then we have 2 times negative 3 would give me negative 6, but adding them would give me negative 1. Then we have negative 2 times 3, multiplying them together will give me negative 6, and adding them together will give me a positive 1. I am looking for negative 1, so I can see right here this is negative 1. This value, negative 1, is equal to b, so I'll be using this to split the center. Let me split the center, so I have x squared uh, plus 2x, and actually I should change the color of this so you can see what I used to split. So I'm going to say minus 2x, sorry, plus 2x, and minus 3x minus 6. And put that back in pink. Minus 6. Right, so factorize this by grouping. So we have this grouped here, and I will rewrite this here. I will pull out, I'll change this to a positive into negative 3x minus 6, like that. And then that would mean I'm grouping the negative 3x with the negative 6. And factoring that, I will get x into x plus 2. If I pull out negative 3 from here, negative 3 into x plus 2. And then I would be able to factor out x plus 2. And then I would have x minus 3. All right, then I will go on to another example now. Now, you may be thinking to yourself, then when it is that we get something larger, right? When we get something larger than this, it's not only going to be these 4 here, it's going to be a lot more. What do you do in a situation when it's a lot more? Well, in a situation that you have a lot more to deal with, so say for example, of 4, you're going to have something like negative 3x squared plus 2x plus 18. What are you going to do in that situation? Well, in that situation, this here is A, this here is B, and this here is C. A times C is negative 3 times 18, and that would be equal to 30, 24, 54, negative 54. Sorry, is that 18? No, that's not supposed to be 18 so high. I ain't going to go that far. Plus 8. Take out that and put an 8. 24. Right? We don't want too high. Okay? Anyway, so we have something like negative 24. Now, negative 24 has a lot of possibilities for it. So what I'm going to do is I'm just going to list the pairs. So I'm going to list the pairs as 1, 4, 124. That's a possible pair. 2, 12. Then 3, 8. And then 4, 6. And then after that, it's 6, 4, but I don't need to write that. All right. So I don't need to reverse these. All right. I can think about it and have them as they are. But since it's a negative 24, I have to realize that one of these would be negative. All right. So all I have to do now is mentally check and see which one close enough to give me 2. So I'm seeing that the difference between these two here is not going to give me 2, neither this, but this is going to give me a difference of 2 if it is that I think one is negative and one is positive. So in this one here, there is a possibility, and I can see negative 6 times 4 will give me 24. But if I take negative 6 and I add it to 4, I will get negative 2. All right, well then, what about this one? I know that if I take negative 4 and I times it with 6, I will get negative 24. But if I add them together, I will get positive 2. So I can see right away that I will be using the 4, 6 pair with a negative 4 and a positive 6. So I use that right now. So I will see negative 3x squared, and then I'm going to have positive 4, no, sorry, positive 6x minus 4x, and then plus, let's see that, the 8. Right, let me put that in pink. Right, 8 and plus 8. All right, so I'm going to factor by grouping. I'm going to take this here as one of the factors, and I'm going to change this to a plus sign, put in here negative 4x, and put in here positive 8, like that. And I can see right away it's negative 4x, so I will be like, okay, factor out this first pair. I'm going to take out negative 3x, and I'm going to get x minus 2. And this one I'm going to take out negative 4, so I'm saying plus negative 4, and I'm going to get x minus 2. And I can see right away I'm getting x minus 2, and I'm getting minus 3x minus 4. Now, because of that minus sign inside of there, I can write this in a few different ways, right? I can write this in a few different ways. What I can do is I can factor out this negative 1 inside of here. So I can say something like negative 1 into x minus 2 into 3x plus 4, all right? And then I can also take that minus 1 and put it in with this other factor here. So this becomes something like negative x plus 2, and then 3x plus 4. And then I can do something even much weirder, and I can just switch this around just so I don't have that positive sign out in front. And notice all three of them is the correct answer, right? Well, all three of those alternatives are the correct answer as well, right? It's just a matter of how you write it for what is required. So most of the time they don't like the positive signs out in front here, so they require that you take it out and just put it somewhere else so that you'd be able to not have that negative sign in front. So this here would be a preferred answer because the negative sign is not in front in each of the terms here, right? It's all a matter of preference. And then let's go to the last one we'll do. And after that, I don't think you should have any problems when it comes to factorization of a quadratic anymore. So example number 5. And we say 6x squared minus 11x minus 10. And then we'll just simply write the factors on the side. And I'm just going to do this mentally now. And I'm saying that's negative 60. I'm seeing 1 and 60. I'm seeing 2 and 30. I'm seeing 3 and 20. I'm seeing 4 and 15. I'm seeing 5 and 12. I'm seeing 6 and 10. 7, 8, 9, 10. Once I reach that, I don't have to worry about anymore. That's it. So I'm looking at negative 60 and I'm trying to get a negative 11 in the middle. And I'm seeing that the difference in between these two is going to give me a negative 11. So I've split it up into the two ways that I can get it. So it's negative 15 times 4 to give me a negative 60. Or it is 15 times negative 4 to give me a negative 60. So that means if I choose to add them together, I would get negative 11. And if I choose to add these together, I would get a positive 11. I need a negative 11, so I'll be using this pair here for the split. So I'll just use that. So we have 6x squared minus 15x plus 4x minus 10. I'm going to group this pair here and this pair here. And I'm going to see that I have, let's see, that's 3x. Yeah, 3x is best. So 3x into x minus 5. And then we have that, which is, I think, 2 into 2x. Oh, yeah, this is a 2 over here. 2x minus 5, right? And I will have 2x minus 5 and 3x plus 2, all right? So this is the end of the quadratic factorization. I'll give you some problems now and you can try these problems. So the problems are, we have x squared plus 7x plus 12, and then we have 3x squared minus x minus 4, and then we have 2x squared minus 5x minus 12, and then we have 4x squared minus 9, and then we have 5x squared plus 13x plus 6. All right, and that's it. Hope that was easy enough for you, and I'll see you on Monday when we start the next week of lessons for Art Math.